everyone, I am Kritik. Welcome to my PPT presentation of Deadlock avoidance using Banker's algorithm. First of all, we're gonna see about what is deadlock avoidance. Deadlock happens when process wait on other circular chain of resources. Avoidance means the system carefully allocates resource so that it never enters an unsafe state. It means a potential deadlocked. In Banker's algorithm is a classic avoidance technique proposed by Digital. Okay, what we are gonna see means deadlock will happen like in a circular chain of resource. We can avoidance means the carefully allocates the resource so that it never enters an unsafe statement. It means we can use the deadlock for the wait or delete the processing, so we can avoid the unsafe situation. In example, we can say we can use Google Pay for transferring money. If any transaction happening, like example, A team has 500 rupees and B has 500 rupees. From A to B we sending amount of 200 rupees. If any server down or any malfunction happens, the first program itself it not happened, and it will if any money is transferred to 200 from A but it not received from the B, the server will tell us server error, and the money will refund back within 3 days or more 3 working days. So it is the deadlock happening in transaction. Okay, now we seeing Banker's algorithm overview. It is called the banker algorithms because the system is like a banker who never allocates more resources than it can guarantee to give back safely. We are also talking about the banker's algorithm where we can allocate the resources and it guaranteed it give back safely. That's the main overview of the banker algorithm. Data structures used. What are the data structures we used here means available vector of available resources. For each type we gonna use the available resources. Then matrix that shows the maximum demand of each process. Okay, then allocation matrix showing currently allocated resource to each process. The allocated resources will show the current allocated resource to each process. Need matrix showing remaining resources such of each. We can see that need formula, need is equal to max minus allocation. Here the steps of the algorithm we gonna see. There are 2 steps mainly we are using in the problem statement. First is safely algorithm and the second one is resource request algorithm. The first one will initialize the work to the available and it finish. If any false happening for the process will find a I, then finish equal to false. The need is will give the work all need resources are available. If resources found, allocated will give work equal to work plus allocation. Mark we can give in that a true value, then the repeat until all process are finished or no such process can be found. If all finish, true equal to safe state, otherwise unsafe state. Okay, now we seeing resources request algorithm. Suppose process P makes a request. If request equal to greater than or equal to need gives processed, else error. If request greater than or equal to available equal to processed, else wait time. Pretend to allocate temporarily. Available is equal to available minus request. Allocation is equal to allocation plus request. Need equal to need minus request. Run the safety algorithm. If safe, grant request permitted. It unsafe, roll back and make a process wait. In the allocation in the deadlock statement we can use a rollback statement or repeated statement, so we can stop the program where it can't go any further more details. Therefore, yeah, we seeing some example here. Let's take an example with three passes P0, P1 and P2, and three resources type we can giving that A, B, C given available equal to 3 3 2 max matrix process ABC P0 P1 P2 753 322 902 allocation matrix process ABC that same P0 P1 P2 010200 P2 302 need formula. See that this is very important. Need formula max minus allocation. We just minusing the max from the allocation, then the answer will be P0 for 743, P1 for 123 and P2 will as 600. Okay, now we going to see the conclusion. Banker algorithms ensures deadlock is avoided by only granting resources request that leave the system in a safe state. Yeah, the conclusion saying about the banker's algorithm ensures the deadlock in every situation and avoided by only resources request that leave the state in a unsafe state. Yeah, thank you for the time you spend for me and listening my channel, and this is my first video uploading in a YouTube, and thank for the opportunity it's given by SIT artificial intelligence department, the HOD ma'am Ratnamala ma'am. Thank you for the opportunity.